Okay. Plug in 1, you get 1, and you plug in 2, you get 4. Okay, so back 2 up 4, back 1 up 1. Does this, so both the absolute value and the straight line had kind of like constant increasing, like there was a slope in some sense. Does this thing have a slope? Not in the same sense, right? It isn't, the rate at which it increases gets faster. Does that make sense? Mm-hmm. Okay. One good thing to notice for graphing this function is the distance between these points. I had a student point this out to me. The distance from this point is called the vertex, to the next point is up 1 over 1, right? In their direction. How far is it to the next point?
Up 1 over 3.
Up, you said it backwards, but you said it meant right thing. Up 3 over 1. Does that make sense? Like that, and that structure will always remain the same as long as you don't have like 2x squared or 3x squared. Do you see what I mean? Mm-hmm. Okay, or you could think that this point from the origin is up 4 over 2, right? So that's gonna be good for graphing.
I think I had a problem like this once, but I ended up with a V-shaped graph.
Like the previous one?
Yeah, but it was a square, but it was a...
If it has a squared, it shouldn't be a V-shaped graph.
Yeah, well, that's what I got was V-shapes.
But then you were wrong. If that's what it means. You shouldn't have gotten a V-shaped graph. You didn't graph enough points is probably the problem.
Probably.
So that would be my suspicion. That's actually why...
If you only graph 3 points here, you would get...
If you only graph 3 points, you'd be deceived into thinking it might be a V. Does that make sense? Yeah. So, and the reason I don't choose, at least in my perspective on this picture, to graph when x equals 3 is because then you get y equals 9 and it's off my grid. Does that make sense? Okay. All right, x cubed. All right, so let's plug in the same numbers. So when x is -2, what's y?
-8.
When x is -1, what's y? When x is 0, y is? When x is 1, y is 1. And when x is 2, y is 8. So it's a little bit off the grid. So it looks about like that. Okay, how about square root of x? Can you plug in negative numbers for this guy? No. Can you plug in 0?
Yes.
Yes. You couldn't if you had 1 over root x, but root x by itself is okay, right?
Oh, sorry, can you see with the last graph?
Oh, of course. Yep. There we go. Okay, so when you square root 0, what do you get? And you can pick numbers that square root nicely. Like, don't pick 2. 2 doesn't root nicely. 1. What's the square root of 1?
1.
What's the next number that square roots nicely?
4.
4. And that gives you 2. So 0, 0, 1, 1, 4, 2. It kind of looks like, it actually does look like it's half of a parabola on its side. Do you see what I mean?
And so we don't plug in a negative.
Why not?
Because then let's figure out where it's at on the graph.
Well, because you're going to get imaginary things and they wouldn't plot on your real number graph. Right? So yeah, the thing is, and also remember we talked about domains? This thing has domain x is bigger than or equal to 0 because in the real number system you can't square root negatives. So, yep. Okay. And then how about the cube root of x? What numbers cube root nicely?
1, 0, 8.
Let's do we'll do 1, 0, 8. That's kind of a funky order, but no big deal. What is the cube root of 1? 1. How about 0? And how about 8?
2.
Can you cube root negatives? Yes, you can. So -1, you cube root it, you get. A -8, you cube root, and you get -2. So 1, 1, 0, 0, 8, 2, back 1, down 1, back 8, down 2. Okay. Good morning. It's okay. At least you showed up. All right, so let's talk about graphing stuff. It's a little bit more complicated. So I've got x squared plus 2. Let's pretend for a second you're not sure what's going to happen, and let's plug some numbers in, and then there's going to be a very, very obvious pattern. So if you plugged in numbers, such as our typical ones, -2, -1, 0, 1, and 2, what do you get for your y's? What's the first one? So first, when you plug that in, you square -2, right? And then add 2, so you get 6. Does that make sense? How about the next one? You plug in -1, -1 squared is 1, plus 2 is 3. Plug in 0, you're going to get 2. And then you're going to get 3 again, and you're going to get 6 again, right? So it goes through -2, 6, -1, 3, 0, 2, 1, 3, 2, 6. How is this thing related to y equals x squared? Yep, this is y equals x squared shifted up 2. So what you can say is if you know what y equals x squared looks like, just shift it up 2 and then graph it. Does that make sense? Okay. And often this thing, the x squared, that's often called the parent function. So the thing you translate. And so it can be helpful to graph that and then move it. If you don't have to, that's fine as well. So this one. So I'm going to actually graph the parent function. So what is the parent function that I'm going to shift? And how is it going to get shifted? So the thing you're going to shift is square root x, which goes through 0, 0, 1, 1, and 4, 2. Right, that's the picture you have above. How does that thing get shifted? Down 5. There you go. How about the graph of absolute value x minus 1? What does the parent look like? The parent is y equals absolute value x, and it is a v, because it's an absolute value. And then what happens to it? It goes down 1. Purple graph is my final thing. Because this class is nice and small, when I do tests on this, I can bring in pens and give you extra colors if you want to do your graphs in colors. So, or it's a good excuse to go out and buy pens because pens are fun. My definition of fun is warped. I'm old and boring. Okay. So if you have a function y equals f of x, and you've got some positive constant c, what is f of x plus c? It's the graph of x shifted how?
Up by C.
Up by c. And then f of x minus c is moved down c. Okay. So now the next thing, so that's vertical shifts are obtained by adding a number outside the function. Horizontal shifts are tricky. They don't do what you expect. What you would expect is for the square root x graph to go backwards, right? Is that what your first guess would be? Mm-hmm. Okay, so it's wrong. And here's how you can tell that it's wrong. Start plotting some points. And the first thing that I would check here is what is the domain of this function? So we talked about this yesterday. For square roots, the thing you square root has to be positive, right? Which means the x minus 3 has to be bigger than or equal to 0. That's what it means to be positive. Which means x has to be bigger than or equal to 3. Meaning the numbers you plug into this guy have to go from 3 up. And if you tried to plug in 0, you're going to get square root of -3, which is an imaginary number, right? Okay. So make a table, we'll plug some numbers in, and we'll figure out what happened. So the first number you can plug in is 3. And when you plug it in, first you do 3 minus 3, which is, and then you square root it and you get 0. Next, let's plug in 4. 4 minus 3 makes 1. Square root of 1 is 1. What's the next number to plug in that's going to work out well? 7. Because 7 minus 3 gives you 4, and 4 roots to 2. So this goes through 3, 0, which is on the x-axis, 4, 1, and 7, 2. So how did your square root x shift? It shifted right 3. You see, it was the opposite of what you see. Another way I've seen that explained is that it takes the y-axis and moves it backwards 3 units while the square root x function stays fixed. Which would also explain what's happening there, is that the x's all go backwards 3, which moves the y-axis backwards 3. So that's one way also to think about it, but it's the opposite. And you can convince yourself that's what it is by plotting points. It's not very hard. Now it's just remembering the stupid thing. Okay, so for this thing, what is my parent and how is it going to get shifted? And you can tell because of the whole little squared thing outside the parentheses there. So your parent is x squared, and is it shifted left or right? In this case, it's left, and how many units? 4. I'm going to warn you guys that I am incredibly dyslexic with left and right. Like, I don't know, I have to use my hands to tell what's what. So if I shift something the wrong way, please say something. Like I might say left and might go right. 1, 2, 3, 4. And there's your picture.
I'm like that after it's been mentioned lots of times.
What's that?
I can't tell left from right when it's been mentioned lots of times, but like if it's just like one situation, I know what it is.
Yeah, it's just, I think things that come in pairs are just hard. Okay. All right, how about this next one? So how can you tell what the parent function is? What's the hint? There's this cubed thing, right? Does that make sense? So that means your parent function is x cubed, and how is it shifted?
To right.
Shifted right 2. And so x cubed goes through 0, 0, 1, 1, 2, 8, which I know is off my little grid of 7. Somehow grid of 10 was just too much. And that gets shifted, every point goes right 2.
So when you ask how in the graphs way it's compared, do you have to draw the parent function?
No, you don't have to draw the parent function unless I explicitly ask for it in the directions. Yep, so as long as you get the shape right and the points that you plot are the right distance apart, you're fine. But if I count and your point, like if this point right here is the wrong distance from that point right there, you might lose points. That's one reason it is also helpful to plot the parent function. Does that idea make sense?
How would you rotate or reflect?
Oh, we're gonna get to that. Yep, we'll do some of those. Okay, so in summary, if you have a function f of x and a positive constant c, what does adding a number inside the function do to it? Make it go that way or that way? Left, yep. So left c, and if you do f of x minus c, it shifts it
Right.
right c. And these two things can also be combined. I actually think that there are no textbook problems like example 5, but I'm not exactly sure why that is because it's a completely legitimate question. So like this one, what is the parent function?
X.
Almost. Absolute value of x. And how is it it's shifted in 2 ways. It's shifted up,
1
up 1, and then it would go
over 3 to the right.
right 3. So I'm going to draw the parent in. You don't have to, but I think it's useful. So there is the parent and shift it up 1, right 3. Does it matter what order you do the shifts in? No, you can also go right 3 and up 1. It's the same thing. So up 1, right 3, and the graph retains the same basic shape. What is the domain of that purple picture? All real numbers? What is the range of it? What's the lowest y value that happens?
4,
1. This point
Oh,
right there,
okay.
the y coordinate is 1, right? So that's
Yeah,
the lowest
I was
y
just
to infinity.
Crossing of the x-axis, or the y-axis.
Oh, you're thinking about the y-intercept. Yep. Okay, how about this one? So x plus 2 squared minus 5. What is the parent function?
X squared.
X squared. Okay, that's what it looks like. And how is that shifted? Down 5 and left 2, exactly. So 1, 2, 3, 4, 5, 1, 2. So that's the new, it's called the vertex, the lowest point. 1 over 1, 2, 3. And if you have to take calculus, this graphing thing comes up over and over. My poor calculus 2 kids had to graph a whole bunch of parabolas recently, and they wanted to cry. They thought they could forget it. Can't forget it. It's just like, it's like a language class. You can't forget your vocabulary. Okay, so one more. Oh, and just for FYI, what is the domain of this function? Is there any stopping point from left to right? Nope. What is the, so the domain would be all real numbers. What's the lowest y value that happens?
0.
No, of the purple thing.
Oh, purple.
Would be -5 up to infinity. The purple one, the black one would be 0. Okay, how about this thing? What is your parent function?
Square root.
Square root of x. And then how does that parent function shift? To the left 5, and then up 4. 1, 2, 3, 4, 5, 1, 2, 3, 4. This picture is a little bit more interesting because it actually has a domain and range that are both restricted. So the domain, look from side to side. What's the first number you could plug in? What's that x coordinate of that point? So everything from -5 on up is good. What is the lowest y coordinate that happens? 4. Okay, so Cole asked a good question. He said, how do you get reflection and rotations and stuff? So, now here is a technical thing about this y. We're gonna plot y equals -x squared. Now, if I plug in a number, like let's plug in +2. The y is equal to -2 squared. Is that negative squared? No. So what this means is that you take x and you square it, then you multiply it by the negative. It's officially order operations. First you do exponents and then you multiply. Does that make sense? So when you plug in x equals 2, what is the y? -4. When you plug in 1, that's -1 squared, and you're going to get -1. 0 gives you 0. -1. Now here's a good hint. I think this always works. If you always put your inputs in parentheses, you're not going to make mistakes with order operations. It's like when I input -1, that's negative parenthesis, -1 squared. The most common mistake here is students want to cancel those negatives. But does the negative in front cancel the negative in the parentheses? No, because first you square it, which makes it positive, and then you make it negative again. Tristan closed his eyes and fell asleep. Good morning.
I'm still listening.
Okay, when you plug in -2, negative parenthesis, -2 squared, what's that going to give you? -4. Another way to think about that negative sign, if you don't like it, is think about it as -1 times x squared, and then you can see the PEMDAS even more. first two squared, then multiplied by negative 1. Okay, over 2 down 4, over 1 down 1, 0, 0, back 1 down 1, okay, so that's what the picture looks like. What did that negative in front of the x squared do to the parabola? Flipped it over what? So this is flipped. So we'll say y equals x squared flipped over the x-axis. Okay. Another way to think about parabolas I think is pretty useful is that if you've got positive x squared, it's a happy parabola. It's like a smiley face because it's positive. And if it's, like, okay, whatever. And if it's negative, it's sad. All right, cheesy jokes. You're gonna remember them if you don't want to. Now, how about negative root x? So do you think the same pattern is gonna happen here?
Probably.
Yeah, so this negative is gonna take the picture of root x and it's gonna reflect or flip. I can't spell, over the x-axis. So here's what regular root x looks like. What is negative root x going to look like? So we'll go through 0, 0, right? This point right here reflects down there. Okay. And this point up here reflects down there. So the purple thing only is my final graph. Like, don't confuse the fact that that black thing is there as meaning it's the answer. It's just it's like the work. Okay. Just for practice, what would the domain of that purple function be? What's the first x you can plug in? Uh-huh. And up to infinity, right? Is there a lowest value that happens in this case?
Yes.
No, because this keeps going down forever and ever and ever and ever, right?
Oh, I thought you meant lower x.
Yeah, so there is no, there is a lower x, but there is no lower y, right? And the highest y is 0. Jeremy, you had a question? No, you didn't? Okay. All right, so putting a negative in front of a function reflects it over the x-axis. What happens when you stick a negative inside? It might be like, you might want to protest a little bit. You're like, you can't square root negative numbers, right? This is not okay. Do you agree with that?
What if x is negative?
What if x is negative? Does that make sense? So with the regular root x function, you can plug in positives only, right? When you stick a negative sign inside of there with the x, that means you can only plug in negative numbers. So let's plug in some negative numbers and figure out what happens. So, 0 is fine still, right?
0's awesome.
0 is awesome, yes. When you plug in negative 1, the double negatives cancel, making a 1, and then that square roots to 1. And then negative 4, that's going to make 2. So 0, 0. Oh, back 1, up 1, back 4, up 2. So if you put a negative inside f of x, this reflects over y-axis. How would you reflect over both the x and the y?
A negative square root negative x.
You would do negatives both places. Does that make sense? Negative inside and negative outside. Okay, well, and also one more thing to explain. Why didn't I show you this pattern with a parabola? What happens with a parabola if I reflect it over the y-axis? Nothing happens, right? Do you see what I mean? Like this half will reflect onto that half, and this half reflects onto that half. It's not any different. Okay, alrighty. So in summary, if you have negative f of x, this is the graph of f of x reflected over the, I think that's wrong, x-axis. I take all my positive y's and make them negative y's, right? That does this flipping thing. And f equals negative x is the graph of f of x reflected over the, that one's the y-axis. Okay. Now there's stuff, these are a little bit different than the previous ones. How are they a little bit different?
The 2x squared.
Yeah, it's 2x squared instead of x squared. And I think the best way to get the picture exactly right is to plot points for 2x squared. You can do that mentally, it's not very hard. And then after you've done that, shift that new parent. This 2x squared is related to x squared, it's just stretched out. But I've found that for students, the best way to find those points specifically is just to plot some points. So for example, when you plug in 0, you're gonna get out
3.
what?
Well,
Oh, I meant into 2x squared. So sorry, you're right. You would get 3 and plug in the original function. But let's use the whole shifting idea. So this will be the graph of f of x is 2x squared moved up 3, right? So if you plug 0 into 2x squared, you get 0. If you plug 1 into there, you're going to get 2. And if you plug 2 in, you're going to get 8. Okay. And then your final answer is to move that thing up 3. And you don't have to draw those points that are super far off the grid. Just convince me that you know that this thing is U-shaped.
So the 2x, what is the 2 doing to it? Shifting it up.
Nope. That 2 takes y equals x squared and does a vertical stretch,
Okay, which is why it's not as.
which is why it's not as wide. Does that make sense? So it takes the points that were the original y's and it pulls them up by a factor of 2. So if it's helpful, I can also graph the original parent on here. Just having to pick a color that's not super, red. So those are the points that that's y equals x squared, right? And what this function does is it takes all the y values of that and multiplies them by 2. This was a y value of 1, it becomes 2. That was a y value of 4, and in the 2x squared it becomes 8. Okay. All right, how about this one? So what would be the parent that you would, like, say, plot points?
3 absolute value.
Mm-hmm, exactly. And that's gonna go through 0, 0. What do you get when you plug in 1? 1. No. I think you get out 3.
-2.
Oh,
I was thinking, I'm just, this thing, you were thinking about, yeah, if you plug into the other one, yep. What if you plug in -1? Also 3. And how about when you plug in 2? 6. Tristan, I don't believe that you're not sleeping. Like, it's just too hard to believe. I should get stuff to throw at people when they fall asleep or use their cell phones. That'd be awesome. And it's not high school, I probably can't get fired for it. Yes, woo. Okay, so, and now you take this picture and you move it down 5. And since it's got recorded, I mean, throw soft things gently. Okay.
Well, if I was sleeping, my head would either be cocked fully back or on the desk.
Or you'd snore.
Yeah, that too.
Yeah, quit closing your eyes. Buy some droplets to deal with the dryness.
It's not the dryness this time, it's
Whatever.
sleep.
I don't care. Deal with it. It's life. Yeah, exactly. Get a Red Bull, drink coffee, whatever. All right, so that's the final answer. Okay, and now last one, like this, 1/2 x squared. So if 2 made the graph taller and skinnier, what do you think the 1/2 is going to do to it?
Widen it.
It's going to make it wider. And throw something at you, Tyler. You got your cell phone out. Now throw stuff at cell phone users too. That might hurt your cell phone. 1/2 x squared.
Wait, 1/2's gonna make it smaller because why?
1/2 is going to make it wider. So think about the 2, for example A, that made it taller and skinnier. 1/2 is going to make it fatter. You'll see that by plotting points. Let's just, you can try. Okay, let's plug in some numbers, and you can choose which numbers are nice to plug in. Like, pick one.
0.
0, like 0. Do you want to plug in 1?
No.
Nah. How about 2?
Choose good.
1, I say nah because you get a fraction, right? Okay, so you plug in 2. 2 squared is 4. Half of 4 is, don't let me down, 2. What's the next nice number to plug in?
-2.
Sure. Also gives you 2. How about 4? 4 squared is,
16.
half of 16 is
8.
8. -4, you get also 8, right? So you got 0, 0, 2, 2, and -2, 2, and 4, 8, and -4, 8. Okay, so that's the, you see how that made that's the parabola but sort of squished as opposed to stretched? And then how does that thing get shifted?
Down 5.
Down 4.
So.
Yes.
Stretched. Sorry, I'm trying to understand fractions. The other one's stretched vertically.
And this one is squished vertically. The thing is, you can phrase those things 2 ways. So in example A, it's stretched vertically but compressed horizontally. Does that make sense? But in this one, it is compressed vertically but stretched horizontally. So it depends on if you're talking about horizontal or vertical, if you'd say a stretched or shrank. Does that make sense? You can think that it is an x squared thing stretched out if you think about stretching it out this way. That is definitely true. Okay. So a couple of those things just in combination with shifts both left, right, and up, down. So this guy, I've got absolute value, and I have a 3 inside. Here's a great trick. You can factor out that 3, and then absolute value it. So you can take this and make it into -3x plus 3. Does that make sense? And then you can absolute value that 3, which is just 3, right? So that becomes -3 absolute value x plus 3. So that's the thing, they're going to have the same picture as the other thing, they're equivalent, it's just a better way to write it. And you can think about your parent 2 ways. I'm going to think about the parent as being 3 absolute value of x. Hey, we did that one up there. And if that is your parent, how does that thing get shifted? Is it- It does not go up. Does it go left or right, guys?
Left.
It goes left 3, and it also, what does the negative do to it? Flips over x. The reason it doesn't go up is there's no constant added on the end. Remember when you add stuff inside the function, it's a left-right shift.
Yeah, I was talking about the slope.
Oh, the slopes are definitely 3s, yes. Okay, so here is what the parent function looks like. We graphed that in the previous example. And then that thing shifts left 3, and then flips over the x-axis, and now it's upside down. Okay. How about this guy? What is the parent function? And 3 things happen to it. It gets moved.
2.
Yep. Here's one sort of technical, well, I'm going to do this and show you something can go wrong. But yeah, there is you have to do the reflections first, and I'll show you why, okay? So you go reflect over. You go up 2, and then you go right 1, correct? Okay. So here's what the parent looks like. I'm going to do that reflecting in a couple steps. So first you reflect. Can you guys actually see that orange? And then what happens to the reflected thing? It goes up to the right one. Okay, so up to right 1, up to right 1, up to right 1. Okay, there we go. And so this thing is your final answer. No, I said that it matters what order you do the reflecting in, didn't I? Let me show you why. You can confirm that that purple graph is the right thing by plugging in numbers. Does that make sense as well? So if you tried to do what Cole said, which is a completely reasonable thing to try. So you said first you would want to go up 2 and then over 1, which makes it look something like that, right? And then reflect over the y, and that throws the graph way the h down there. Does that make sense? You could, yes, I hear what you're gonna say, is if you just took that point and fixed it and then flipped it, that's all right.
Well, if you were to reflect over 2,
Then you're fine.
okay,
Does that make sense? But that wasn't what you were gonna say.
that's what I
You
was
probably,
thinking.
maybe you were going, that's what you were gonna do, but not how you were gonna say it. Is
Okay.
that what you were also gonna say, Jessica?
No, I have no idea what you're talking about. I was gonna
Okay.
say,
Well, if you imagine a line,
No, I understand what you were saying. I was asking Jessica what she was gonna say.
I was gonna say, what if you just, like the sort of bottom point, yeah, that one, what if you just set that as like 0?
That's what he's
and
trying to say,
zero?
you would
Okay.
do. Yep. So what you can do if you do the shifting first, you don't reflect over the x-axis anymore, you reflect against the horizontal line y equals 2. And that works. And most students kind of get that intuitively. They get like, okay, I should move it and then it's going to just flip upside down. But if they interpret what they say too literally, they flip it over this axis and really throw it down there. And if you say those things, if you said these things in the opposite order and your last thing was reflect over x, you haven't kind of done what you said. Does that make sense? But you're right, that you could move it and then this is your new fixed point and then it flips over that. That will always work. Most students get that intuitively. I just want to point out why saying reflect over x is kind of wrong-ish. Okay.
So, I'm sorry, just to sum up real quick, so reflect over that X would be easier, obviously any reflection.
I think it's
first.
easiest to do any reflections first. And it's kind of like a PEMDAS for graphing because it's the multiplying. Does that make sense? So you can think about it as being the first operation that has to happen. If you are able to keep track of stuff and kind of manipulate things correctly, you can make it a little bit more wiggly and you can do it last if you want to. But it wouldn't hurt to do it first. So that's how I just graph. I just do the reflecting first and then shift from there. But it's not the only way. Okay. So this one, do you see how there's a minus sign right there? And it's what's in front of the squared-ish stuff. So that expression is the same thing as -1/2 stuff, x minus 2 squared, plus 4, right? You can change the order of subtraction as long as the negative sign goes with the thing that it's in front of. So what's the parent function here?
X over 2.
Mm-hmm. The parent is, can I just say 1/2 x squared? But you know, x squared isn't necessarily wrong. And we graphed that one already, didn't we? So it goes through 0, 0, 2, 2, and 4, 8. And 3 things happen to that parent. One is reflect, right? 2 is how much up? And then 3 is to the right. How many units? 2. Okay, so I'm gonna reflect it down.
So if it was negative x minus 2, that would be when you would reflect over the y-axis?
Yeah, but that won't happen with parabolas because you end up back on itself. Yep. And it's a bit more tricky than that. We will have examples of that later. Yeah, Willow.
So if the negative is outside, it always goes over the x.
Exactly. If the negative is outside, it's always over the x, and if it's inside, it's always over the y. Exactly. Kind of like how I think about that is I think about when you do something outside the function, it's an up or down shift or an up or down flip. Inside the function is a left to right shift or a left or right flip. They kind of preserve the same orientation. Okay, so let's move this picture up 4 and right 2. 1, 2, 3, 4, 1, 2. Okay, 1, 2, 3, 4, 1, 2. Okay, ish. Did I do the wrong thing? I told you I'm dyslexic, didn't I? Yep. Crap, and erasing is like not always possible.
Write it in blue.
Okay. I'll write it in blue and we'll write it really, really dark. It was supposed to be, is there an undo button? I can't always figure out my software, guys. I'm sorry. I'm too old.
Right above the magnifying glass.
Shh, we're just gonna, that's the right one, okay? I made a boo-boo. The purple one is wrong. I told you I was gonna mix up left and right at least once today. I was just testing if you were awake and you passed my test. Tristan didn't, he's still asleep.
Finding it off.
Mm-hmm, yep, okay. All right, so suppose you have a graph G that's formed by applying this sequence of transformations to this given function f. I want you to give me the equation of G. So if you want to take x cubed and you want to shift it 5 units to the right and 4 units up, what would the equation be what would it look like? What would the equation look like, not the picture? So there'd be something inside the parentheses and something outside the parentheses, right?
Inside would be minus 5.
5 units to the right. Now see if I can not mess this up. Yep, it'd be minus 5. And then 4 units up would be plus 4. Okay. This one, the graph of x squared, is reflected over the x-axis, vertically stretched by a factor of 2, shifted 4 units to the left and 2 units down. Okay, so the equation for g of x, so Phil, we know we have a squared, right? Because it said x squared. So 2 units down would be a minus 2, right? How would you get the 4 units to the left?
Plus 4.
X plus 4. How would you get the flipping? Uh-huh. And then the way you get this whole vertical factor of 2, you put a 2 there. Okay, so that's the only thing that's different. That's kind of like example 7a where we had that thing stretched out by 2.
So
Yeah, go ahead.
when you're stretching, you do it outside.
Yes, there is also something that happens when you just make inside of a function. It's just we don't have any pictures yet that show us good examples of that. If that makes any sense. Like doing something inside a function also does some kind of stretching of some sorts, but it just isn't as like obvious without better graphs that should display the behavior more well. So.
So it's either stretched or compressed. If it's a negative number, it's,
Well, the negative does the flipping.
oh, the stretch.
If it was compressing, it'd be a fraction. Okay, does that make sense? But a positive fraction because the negative does the flipping.
So on the example before,
Yes.
since f of x is x cubed,
Yeah.
shouldn't the equation be x minus 5 cubed?
Okay. So the last thing we'll start in the next 5 minutes and just finish next time is something called an even and an odd function. These come up all the time, all right? So this is not going to go away, don't forget it. So if f of negative x equals f of x, then f is called an even function. Here's a really easy example. If f of x equals x squared. What this thing says is that when you plug in negative x, it's the same thing as plugging in positive x. Okay? And so how you check and see if the function is even is you plug in negative x, and when you simplify, you see if the original function comes back out. Okay? And the example that's super easy is x squared. If f of negative x is the same as taking and negating your original function, that is called an odd function. And the easy example is x cubed. So like when you plug in negative x, you input it in parentheses. And then if you multiply a negative by itself 3 times, you get negative x cubed, right? So negative the original function. And how you check for even oddness in both cases is you plug in negative x and you see what happens. It is possible for functions to be neither. Okay, you have some functions are even, some functions are odd, and a whole bunch aren't either one. Yes?
For odd functions, why would f of x equals x not work?
Oh, f of x equals x is also an odd function.
Just making sure.
Yep, that is. It's just that it's not as sort of interesting as x cubed. Okay. And these functions also have symmetry, and this is the useful thing that comes up in calculus classes. So think about x squared. What does it look like? It has symmetry about the y-axis. All even functions have that property, because when you plug in a positive x, you get the same y as plugging in that negative x. So every single even function has symmetry about the y-axis.
What if you were to shift it forward? Then it would have symmetry over like x.
It's only an even function if the symmetry is over the y-axis. If you shift it left or right, you lose that symmetry and you're no longer even. Okay, so once that symmetry is lost, you're no longer that kind of function. Odd functions, think about what that x cubed looked like. It looked approximately like this, right? That has some kind of rotational symmetry. And what this is called symmetric about the origin. It also is a reflection of, say, like this part of the graph, both over the y and then over the x. Okay, so we're going to do example 10, and then you can go because, people were late, so you shouldn't start packing your stuff up early. Okay. It's just your lunch. Okay, so how you always start checking is by plugging in negative x. So f of negative x is input negative x to the 4th plus 1. And on your quizzes, you have to show me that you know to do that step. What happens when you take a negative to the 4th power? Becomes positive. And now it's x to the 4th plus 1. And you check and see, is that my original function, negative my original function, or neither of the two? So is this the original function? Yes. And if when you plug in negative x, you get the original function back, that means your function was even. And if you felt like it, you could confirm it by graphing that thing and seeing that you had y-axis symmetry. It'd be a way to check your answers.
So if it's the same, it's even, if it's opposite, it's odd.
And if it's something different, it's neither. We'll do one of each of them, okay? G of negative x. So that's negative x to the 3rd plus 1. If you multiply negative x by negative x by negative x, you're still left with a negative. Okay. Is this equal to the original function? No. So not even. Is it equal to negated original function? Careful with that. Yeah, if you were to negate the original function, both the x cubed is negative and the 1. So it's not equal to the negative either. So this is also not odd, which means it's neither. It is possible to be neither. If you were to look at that picture, that's a cubed shifted up 1. Does that make sense? is that cubed shifted up one, does it have the original symmetry anymore? No. Okay. Okay, let's try one more. Uh-huh. Okay, one more. H of negative x, so that's parenthesis negative x to the fifth plus negative x. So if you fifth power negative, it's still negative. And then we're gonna have minus x. Is it the original function? No. But is it opposite the original function? Yes. So same thing as negative h of x, this function is odd.